Grade 4 Module Slopes and Angles Project 2 Incline to Lift. Look at this picture. Tell me, what is the purpose of the ramp in the picture? The ramp and any other such surface that lies at an angle to the ground is an example of an inclined plane. Inclined plane is a type of simple machine.
Eureka! This unit is divided into 5 programs. The program you're about to see is on the inclined plane. Then there's a program on the lever. Next comes mechanical advantage and friction. Then the screw and the wheel. And finally, the pulley. But our story begins with the inclined plane. You haven't really got enough force to lift that barrel, have you? How much force do you need to lift it? Well, how much does it weigh? So you'll need at least 800 newtons of force to lift it into the back of the truck. How far is that? About 1 meter? How many joules of energy will it take? Well, figure it out. Energy is the ability to do work. Work equals force times distance. 800 newton meters of work, or 800 joules of work, which is the same as 800 joules of energy. But you still can't lift the barrel. There's something wrong somewhere. Perhaps it's because you have to exert your energy all at once. If only you could load the barrel onto the truck a little bit at a time. If you could slice it into 4. Then you'd have 4 200 newton slices of barrel. And you'd only need 200 newtons of force to lift each one. That's easy, isn't it? You're using your energy more effectively now. You're spacing it out over a longer time. But you don't get anything for nothing. Although your force is cut down to a quarter of what you need to lift the complete barrel, each time you lift a quarter of the barrel, you exert that force through 1 meter. Which means that you lift the 4 quarter barrels through a total distance of 4 meters. What you're winning on the force, you're losing on the distance. It's a sort of trade-off. The greater the distance, the less force you need to exert. Very neat. But you can't go around breaking things into pieces just because they're too heavy to lift. If only you had a machine that would allow you to trade increased distance for decreased effort or force. Here's your machine. Yes, I know it's just a plank, but it's also a machine. Try and get the barrel into the back of the truck now, and you'll see why. Magic, isn't it? No, it isn't. It's exactly the same trade-off you got when you split the barrel into 4. The plank is 4 meters long. Instead of moving the barrel 1 meter by lifting it straight up, you're moving it 4 meters by pushing it along the plank. You only need to push it with about a quarter as much force, with only about 200 newtons instead of 800 newtons. But since moving 200 newtons through 4 meters is the same as moving 800 newtons through 1 meter, it will still take roughly the same amount of energy to move the barrel by either method. That's why we can call the plank a machine. It doesn't reduce the energy you need to do something, but it does help you to use your energy more effectively. You think you've just made a new discovery? Think again. How do you suppose they built the pyramids 5,000 years ago? They didn't actually use a plank, of course, but a ramp of earth, which is exactly the same principle. And you use the same principle yourself every time you stand on an escalator. Because the plank, the ramp of earth, and the escalator are all 3 examples of the same type of simple machine. They are all sloping, and they are all flat. So physicists call this variety of machine the sloping flat thing. Well, those aren't the exact words they use. They take the Latin-derived word for sloping, which is inclined, and the Latin-derived word for flat, which is plane, to come up with this phrase. So if you're allergic to elevators, why don't you take the inclined plane?
Outcomes of the video. It is easier to push a load up an inclined plane than to lift it directly from the ground. The amount of force needed to push the object is lesser but has to be applied for a longer distance. Now look at this. This is a slope ratio, rise and run. Suppose we have to lift a barrel to point B. We can do it by lifting it from A to B or by pushing it up from C to B. Answer the following questions. Is it easier to move the barrel from C to B or from A to B? Answer is from C to B. Next question. Is the distance travelled by the barrel same in both cases? No, it is not same. Next question. Is the force required to move the object same in both cases? No. Gravitational force, gravity. It is a force which attracts things towards it. Like Earth has gravitational force, when you throw any object upwards, it will come down due to gravity. It is a non-contact force. Friction. Another force is friction force. It stops things to move or hold things, like grip of your pen, and it is a contact force. Here I am launching Creya application for project 2 incline to lift. Module slopes and angles, project incline to lift. These are the materials that we require. This is angle girder 120, angle girder 60, building block 30, hinge block claw, cog wheel T20, spring cam, clip axial 75, link, building block with groove, base plate. So let's begin with the steps. Students will build a model of slope or an inclined plane and will experiment with their model to find out at what slope objects will start sliding on the inclined plane. First project is start the model with a building block 30. So this is building block 30. Step number 2 is slide the pin of an angle girder 120 into the building block 30 as shown. So here I am sliding angle girder 120 into the building block 30, just like shown in the picture. Step number 3 is slide the pin of another angle girder 120 into the building block 30 such that it is touching the first angle girder 120 as shown. We just have to see the orientations of the angle girder. Next step is connect the pins of two angle girder 120 to the first two angle girders 120 as shown here. Attaching another pair of angle girders. Next step is to the topmost grooves of the angle girders 120 connect the pins of two spring cams as shown. So here I am attaching spring cams. Next step is connect the groove of a building block with pin and groove to the two spring cams. So this is building block with pin. Next step is connect a building block 30 to the pin of building block with pin and groove as shown. Just like shown in the picture, I am attaching building block 30 to the building block with pin and groove. Next step is slide the pin of a hinge block claw into the topmost groove of the building block 30 that you attached in step 7. This is hinge block claw. Step number 9 is insert a bearing sleeve into the hinge block claw. You have completed building the body of the inclined plane. Set this model aside for the time being. So I am setting it aside. Now stop. Slide the pin of an angle girder 120 into the first groove from the far end of base plate. So this is base plate and this is angle girder that I am sliding to the first groove. Next step is slide the pin of another angle girder 120 into first groove opposite to the first angle girder 120 of the base plate, and I need to see the orientations of the angle girders just like this. Next step is slide the pins of two angle girder 60 onto the topmost grooves of the angle girder 120. Again have to see the orientations of the angle girder 60. Next step is to the topmost grooves of the angle girder 120 attach the pins of two building blocks with pin and groove such that both are touching each other. So with the help of this building block I am connecting both the angle girders. Step 14 is connect the grooves of both building block with pin and groove with the help of link 30. You have completed building the support for inclined plane. So this is support for the inclined plane that we are making, and here I am using link which used to connect the things. Next step is you can attach the body of the inclined plane to the support by inserting a clip axial 75 through the holes in the angle girders of the body and support as shown. Try connecting the body to the topmost pair of holes in the support as shown. So just like this we will make an inclined plane with the help of this clip axial 75. I am inserting this clip axial through the holes in the angle girders. So inclined plane is almost ready. Next step is to fix the clip axial 75 in place. Attach a cog wheel T10 narrow to one of the extended parts of the axial as you can see in the picture. So here I have attached this cog wheel to fix the clip axial. Next step is, as you can see, you can change the incline of the inclined plane by using different pairs of holes in the inclined plane stand. Connect the inclined plane to the fourth pair of holes on the stand from the bottom. What do you observe? Does the building block 30 slide down? Keep increasing the slope of the inclined plane until the building block 30 begins to slide down. Note down at which point this happened. So this building block is easily sliding here at this point, but when I fix this clip axial, this inclined plane to this point, let's see, will it slide or not? No, it is not sliding because this time there is more friction and less gravity. At this point also it is not sliding. Let's see. Yes, at this point it is sliding easily. So at this point you can say gravity is more and friction is less. This is the topmost point. So yes, obviously it will slide very easily. Now let's move to journal question and answer. Using the protractor that you have built, measure the angle at which the building block starts sliding down. Write this down. Is it an acute or obtuse angle? So let's see at which point it starts sliding down. So yes, at this point it is sliding down. So with the help of this model protractor, I am going to measure that which angle it is. It is acute or obtuse. So yes, if we start from zero angle, so it is measuring around, each red block has 15-degree angle, so it is on the second part, that is 30-degree angle. So 30-degree angle is acute angle. Now the next question is, what is the force that is caused the building block to slide down? Is it contact force? At what angle does the building block 30 stop sliding down? We have to see at which angle, on which angle it stops sliding down. So yes, here on this point it is not sliding. So again I will measure it. So from here, if we start with the 0, it is on the point on this angle. Let's move to logbook question and answers. Using the protractor that you have built to measure the angle at which the building block starts sliding down, write this down. Is it an acute or an obtuse angle? It is measured as 30 degree, which is an acute angle. Next question is, what is the force that is causing the building block to slide down? It is a gravitational force. It is a non-contact force. Question 3. At what angle does the building block 30 stop sliding down in the above situation? Is it a contact force or a non-contact force? Building block stopped sliding down at 15 degree, which is an acute angle. It is friction force, which is contact force. Question number 4 is, what is the force that is preventing the building block 30 from sliding down in the above situation? Is it a contact force or a non-contact force? It is a friction force that is preventing the building block 30 from sliding. It is a contact force.